Hello and welcome to my next GCSE video on the sea, atmosphere and materials. In the early atmosphere, many millions upon billions of years ago, there was not much O2. Scientists reckon that maybe there could have been a lot of nitrogen. For example, the atmosphere of Titan is 98% nitrogen. Titan is one of Jupiter's moons. Or it could have been a huge amount of CO2, such as Mars and Venus. Now, what they reckon caused all these different gases in the atmosphere was volcanoes. Now, scientists believe that volcanoes gave out a lot of carbon dioxide or nitrogen, which then filled the atmosphere, but also they give out a lot of water vapour. As the Earth cooled, the water vapour condensed, and that's how we got our seas, oceans and lakes. This is still very uncertain though, because it's quite hard to tell that far back. Now, as we said, as the Earth cooled, water vapour became the oceans. Carbon dioxide in the atmosphere then dissolved in the oceans. They think that almost half the carbon dioxide was lost this way. Now, this caused, as you will see a little bit later in this video, the causation of rocks, in particular sedimentary rock, limestone, which is calcium carbonate. Also, around 1 billion years, very long time ago, they reckon photosynthesis started. Now, photosynthesis is when a plant in particular takes in carbon dioxide and releases oxygen. A plant also needs water and will also release glucose. But in particular, so that's the important thing, it will take in CO2, removing more carbon dioxide and produce oxygen, so we get oxygen in the atmosphere. They reckon at about 4,000 million years ago you had nearly all carbon dioxide, but it started decreasing, nitrogen levels started rising, and around 1,000 million years ago you got an increase of oxygen and then a very rapid decrease in carbon dioxide. Today, we have about 78% nitrogen, 21% oxygen, 0.9% argon, and 0.04% carbon dioxide, and there's quite a few trace gases as well. That's stuff like carbon monoxide, methane, nitrogen oxides, and sulfur dioxide. Now, the amount of these gases can vary, but there are certain things which change that. For example, deforestation means there's less removal of carbon dioxide, less production of oxygen. So that means we can have more carbon dioxide in the atmosphere. If you have a sudden burst of a volcano, you can get sulfur dioxide. In cities, you can get nitrogen oxides because they produce a lot. Lots of different cattle can produce large quantities of methane. A lot of these are quite dangerous to us. But the most common is nitrogen. As he said, it makes up 78% of the air. And the main theory of how that was produced is by volcanoes. Now, this means the atmosphere has always contained a lot of nitrogen, though another theory is that most of the nitrogen was added to the atmosphere gradually due to the reaction of nitrogen containing compounds released from volcanoes. So we all think it came from volcanoes. Rocks. There are three main types: igneous, sedimentary and metamorphic. Igneous is when you have molten rock called magma, particularly again released from volcanoes. It erupts and then goes onto the surface as lava. When the molten rock cools down, it solidifies and becomes solid rock. This is called igneous rock, and they contain crystals interlocked. Now, the size of crystals can vary, and they're determined by the rate at which magma or lava cools. So the slower it cools, the larger the crystals. Sedimentary rocks. Now, most sedimentary rocks form from other pieces of rock, or others form from the hard parts of dead organisms as well, so you find a fossil, generally sedimentary rock. Now, what you have is you have layers of sediment build up on the seabed, and then the layers are pushed together and are compacted and squashed to form rock. Now, these may contain fossils, dead plants, or imprints of footprints or anything. Now, where a lot of these bits of rock come from is when a big rock erodes. Now this can happen by the wind, or like when you see a cliff, or the ocean, that'll be at the bottom of a cliff. And then these bits of rock will be transported towards the sea where they become sedimentary rock. Metamorphic rock. Now, this is when the action of heat or pressure changes rocks, causing new crystals to form. So marble is an example. Marble forms when grains of new crystals of calcium carbonate interlocked tightly. Makes marble harder than chalk or limestone. Now, talking of limestone, you need to know about limestone. Limestone is made of calcium carbonate, that is CaCO3. Now, we use limestone a lot. 50% of limestone is used in construction, 22% is used in making concrete and cement. You've got other uses making glass, making steel, iron alloys. Limestone is removed from the ground at a quarry. You can have explosives which are used to break the limestone into pieces, and then they are cut or crushed into useful sizes. As we said, it's very important. But unfortunately, quarries are commonly in attractive places like the Peak District. They are dusty and noisy, so people don't like them, and they can destroy the original landscape. Now, we make cement and concrete out of limestone, used by heating limestone with powdered clay. And cement is an ingredient in mortar, the mixture used by bricklayers to hold bricks together in walls. Concrete is made by mixing cement with sand, gravel and water, and concrete is used in construction. So you can see how limestone is used. When you have glass, yet again, heating limestone with sand and sodium carbonate. And a chemical reaction occurs and liquid glass is made, which can be cooled to form our glass. Now, a lot of what happens with limestone is you heat it up and you get the thermal decomposition of calcium carbonate. Now, thermal decomposition is when something breaks down under heat. In this case, calcium carbonate becomes calcium oxide and carbon dioxide. Here are some other reactions you need to know. Now, these are all symbol equations because they have symbols. You have to balance them out to make sure they're the same on both sides, so the same number of each element. You have word equations as well, which are just the words for them. So here we have calcium carbonate, CaCO3, becomes calcium oxide, CaO plus CO2, which is carbon dioxide. Calcium oxide, CaO, with water will form CaOH2. This is lime water, which is important in detecting whether you have carbon dioxide. When you have lime water plus carbon dioxide, what it will do is it will form calcium carbonate, which turns the solution cloudy. That's how you know carbon dioxide is there. Also, acids can be neutralised with limestone. If you watch my next video on acid, you will see how this is done. And that is that. Thank you for watching. As usual, any questions, ask me, leave comments, likes, ratings, whatever. Thank you for watching and goodbye.